Today's topic is coastal depositional landform. Some coastal areas dominated by the erosion such as Pacific coast of North America, while others are dominated by the deposition such as Atlantic and the Caribbean coastal region of USA. But reality is that almost all the coast, both deposition and erosion occurred simultaneously but varying in degree and the intensity. Coast is a transitional zone of land and ocean surface. It is an area lying at the interface between the land and the ocean. The ocean works out through the waves, maybe tidal waves or the seismic waves originated due to tsunami, so on. Waves are the strength of the waves and the energy of the waves is an important thing in the coastal geomorphology. The work of waves are basically two types in the coastal zone, that is erosion and deposition, rather transportation. Deposition is not the work, rather when the waves loses the energy and not able to transport the eroded material, then all the material that waves are not able to transport that are deposited on the shore and coastline. Rather, when the sea loses energy, waves drops the sand, rather the unconsolidated loose materials on the coastal zone on the shoreline, and this is known as that kind of work is known as deposition. Deposition happens when the swas that mean incoming waves is stronger than the backwash, and backwash is related to the gravity. So if the swas is stronger than the backwash, that is associated with the constructive wave and that is related to the coastal depositional landforms. The area of deposition, basically the material deposited in the coast and the shore zone. It may be offshore zone, backshore zone, or the foreshore zone, and sometimes deposit in the front of the or the seaward side of the cliff, and sometimes in the cases of extreme event, it's sometimes in the offshore zone. Now the deposition occurs when the waves enters in the shallow areas or the shallow water, and waves enter in the sheltered areas or the bay or covered zone where there is little wind and there is a good supply of material. Next one is the from where the waves or the ocean gets material, which material is deposited in the shore zone by the oceans, rather ocean waves. On deposition process, most of the sediment comes from the larger river system, just like the Ganga, Brahmaputra, show on. The factor and forces in the formation of coastal features. First one is the waves, tide, sediment supply, beach material, tectonic activity, volcanism, and coastal environment. First one is the waves. Incoming waves is known as swas and outgoing waves is known as backwash. Strong swas and weak backwash is responsible for the depositional landform. The strength and the energy of waves is related to the depositional landform. The wave height, wavelength, all are related to the formation of depositional landform. The strength of a waves depends upon the wave's height, wavelength, and the strength of the swas and backwash. Waves are the result of wind blowing over the sea as they approach to the land and they break. So wave breaking and its strength is related to the formation of coastal depositional landform. Next one is the tides. Tides, we are all familiar that spring tide and neap tide. Those are the extreme condition of tides. Those are related to the beach formation or the depositional landform. And sediment supply, basically rivers supply the sediment. Those are deposited on the coast by the a large riverine system like Ganga, Brahmaputra, so on. Basically, those sediment deposited in deltaic zone. So, supply of materials plays a vital role in the formation of depositional landform. Then the characteristic of the material of the beach or the coastal landform. Next one is the tectonic activities. Tectonic activities is we can take an example. In 1999, the super cyclone due to tsunami and earthquake in the ocean basin in Odisha coastal region, that is due to tectonic activities. That type of tectonic activities is related to the coastal feature that may be depositional or erosional. And next one is the volcanism. We are all familiar with the coral reef formation, rather the barrier reef. Those are related to the volcanism and common in the Pacific coastal zone. And coastal environment and recent human interference, rather anthropogenic activities, also related to the coastal depositional landforms. Basically, deposition pattern in the coastal zone depends on the strength of the waves. Waves may be originated by the tectonic activities, by the tidal effect, by the earth movement, by the volcanism, or the normal waves. But strength of the waves control the depositional landform in the coastal region. There are three main factors that affect the strength of the wave. First one is the energy of the waves. The wave energy depends upon its pitch area, or that is the distance over which wind has blown. Second one is the strength and the speed of the wind. And third one is the duration of the wind. These three factors control the strength of the waves, and strength of the waves control the erosional landform in the coastal zone. Basically, if the swath is more stronger, that is incoming waves, than the outgoing, that is backwards, then in and then the coastal zone will be the depositional landform will develop. Rather, that coastal zone is dominated by the depositional land, landform if the swath is more stronger than the backwards. The coastal morphology is ever changing. It changed due to tectonic activities, and its obvious consequence is the waves breaking, rather nature of wave breakings in the coast. So coastal morphology is related to the longshore current and the longshore transportation. Longshore current and the resulting transportation of sediment is only one of the dynamics process that constantly changes the shoreline. So, longshore current and its related transportation, that is longshore transportation, rather it is known as longshore drift, are very important part of coastal morphology and coastal dynamics. Littoral transportation, that is longshore drifting, is the term used for the transportation of basically for the non-cohesive sediments, mainly sand, and in the littoral zone along the shoreline, mainly due to the action of wave breakings. Rather, longshore current and related transportation, that is known as littoral drift or longshore drift, those facts are related to the action of wave breakings. Rather, wave breakings in the coast is the primary condition for the formation of the longshore current and longshore drift. So, longshore current and longshore drift is is very important factor for the coastal depositional, erosional, and transportational work. Now question is, what is longshore current? Better to say longshore, the full form is along the shore, that is known as longshore. That current follows the shoreline along the shore, that is known as longshore current. When a wave, suppose this is the Suez, this is the Suez, and when a wave comes from the ocean, comes from the ocean as a Suez, and and strike on the coast. When waves reach the beach or the coastline, it released a vast amount of energy, or it releases a burst of energy that generates a current. That current moves parallel to the coast. Move parallel to the coast. This is the continental part. This is the oceanic part. Suez is coming from the ocean, and it hits the coastline, and it release a burst of energy that generates a current, which is known as longshore current because it follows the shoreline, that is known as longshore current. When it happens when the waves comes or approach to the beach, suppose this is Suez is coming from the ocean and approach to the beach at an angle, that is Suez, and it Suez carries the material along the beach, and that is backwards. This is backwards is moving back down the beach. This is moving back down the beach and carries material towards the ocean, towards the beach. And here, one more important thing in between Suez and backwards is always at right angle to the beach. Backwards, suppose this is the beach line. Suppose this is a beach line. Always, suppose those are the arrows are backwards arrows. Always observe minutely, all the backwards is almost 90-degree angle, or almost in right angle to the beach. This is 90-degree angle. It's a 90-degree angle beach, and this pattern of Suez, incoming Suez and outgoing backwards, that is perfectly 90-degree or right angle of the shore line, and that kind of attributes generates a current that moves parallel to the coast, that moves along the coast, that is known as moves parallel to the coast, that is known as longshore current. Longshore mean it moves along the, this is the shore line, along the shore, along the shore, along the shore. Okay, that's why it is along the shore, that's why it is called as a shoreline. Along the shore, that's why it is called as a shoreline by longshore current. Okay, longshore current are affected by the velocity of the waves and the angle of the waves. Rather, longshore currents depends upon the velocity and the angle of Suez. When a wave breaks at the acute angle or the steep angle on the beach on the shore, and it encounters a steep beach slope, and longshore currents developed. Longshore current is also related to the ocean erosion, ocean deposition, rather coastal erosion, coastal deposition, and coastal transportation. Longshore current is also related to the longshore drift. Uh, Drifting is the slow movement of the material. Drifting, not very fast moving material. It's a very slow process that is known as drift. What is longshore drift? First one is the formation of the longshore current. Longshore currents related to backwards and Suez. If the Suez comes with the terrific speed and wave breaks on the coastline and release a huge volume of energy, and backwards moves to the ocean within the right angle, in such circumstances a current develops, okay, that moves parallel to the coastline, that is along the shore, that's why it is called known as longshore drift, longshore current. Now, what is longshore drift? Longshore drift and littoral drift both are the synonymous. Okay, uh, sometimes it happens when waves approach to the beach and at an angle, and it carries material always to the beach in a swath and backwards, moving the materials to the sea. And in such processes, a longshore current develops, and longshore current also carries the materials that materials, that movement of the sediments is along the shore, but the movement of the material along the shore or along the longshore current is very slow. The movement of the sediment along the coastline that is associated with the longshore current, this is very slow movement of the sediment that follows the shoreline, that is known as littoral drift as well as longshore drift. Longshore drift and longshore current is integral part of coastal depositional landform, coastal transportation as well as the coastal erosion. The angle at which waves strike on the beach is an important factor because the strength of the longshore current as well as the littoral drift depends upon the strength of the waves. Okay, if the angle is extreme, if the angle of backwash and swirls is extreme, then the longshore current will be more powerful. Okay, this is the basic theme of longshore drift, rather longshore or littoral drift and longshore current. Littoral drift and longshore current is very important part of coastal depositional and coastal transportational landform. It follows the shoreline. Let's have a look. This is the continental part and it's the oceanic part. This is the ocean part. Okay, this is the oceanic part. Okay, and this is the prevailing wind direction, and Suez is coming. This is Suez. Suppose this is Suez, and those are the backwash, and this is the Suez, and these are the backwash. Backwash is almost at right angle to the shore. Almost right angle to the shore. It's the shoreline. This is almost right angle to the shore, and due to continuous swash and backwash is almost 90 degree or the right angle to the shoreline. There is an horizontal direction. There is a flow of water. There is a flow of current that is parallel to the shoreline. This is the shoreline, and this motion of oceanic water or oceanic current develops after the occurring of swash and backwash, and that current is known as longshore current, and the deposition of material along the longshore current, and that material is slowly moving with the longshore current, that is known as littoral drift or the longshore drift. The main depositional landform in the coastal zones are the bars, barrier bars, offshore bar or the longshore bar, spit, bar spit or hook spit or curve spit, loop and connecting bar. It is also known as Tombolo. First one is the bar. This is longshore current. This is longshore current. Suppose this is longshore current. Okay, this is longshore current, and this part is the continental part, and this is the oceanic part, and swash is coming, and backwash is this is backwash almost 90 degree to the shoreline. Suppose this is the shoreline. Suppose this is the shoreline. This is the shoreline. Okay, almost 90 degree angle. Then due to longshore drifting, this is longshore drifting that moves parallel to the shore, along the shore. The small deposition of littoral material, littoral drifting, a small deposition of sand, that is very loose and consolidated material deposited along the shoreline. This is also the parallel to the shore. This is also the parallel to the shore. This is known as bar. This is parallel to the shore. This is also the example of a comparatively large size of bar parallel to the shoreline. This is shoreline. This is known as bar. Bar basically parallel to the shore. Second one is the barrier bird. This is the barrier island. It is sometimes called as an island. If the barrier bird is grows and become larger in size, it is also called as a barrier island. And it also develops parallel to the shoreline. This is the shoreline. Suppose this is the shoreline. This is the shoreline and moves parallel to the develops parallel to the shoreline. It may be developed as an attached to the coast or move away from the coast. There is a distance between the coast and the bar zone. Third one is the offshore bar. Offshore bar is also parallel to the shore. It is also parallel to the shore. It is offshore bar and but not attached to the shore. Here there is a not this zone is not attached to the shore. This is the continent or shoreline. This is the continent or shoreline not attached to the shore. And at the high tide, the offshore bed is below the sea. At the line of breakout reveals its location as the waves break on it. During the low tide, we can see the offshore bird. It is towards the ocean surface and it is not visible throughout the day. Only during the low tide we can observe it. It is parallel to the shoreline but not attached to the shore. Spitbird also the bird. It is also parallel to the coast. This is the coastline. It is parallel to the coast. And this is the zone of littoral drift. And it's parallel to the littoral drift zone and the parallel to the coast. But one end is attached to the continent. That is, that part is attached to the continent. But end is projected in the open sea. Its end is projected into the open sea. That is known as spit. Okay, one part is attached with the continent and other part is projected in the open sea. That is known as spit. It also the parallel to the shore. And Chilka Lake and it's is an example of Chilka Lakes and its related bird zone is an example of spit. It is almost 50 km long. In Kalingapattam near the Cochin, there are also 16 km long spit bird. Next one is the hook or the curved spit. This is nothing but the carved form of a spit bird. It also parallel to the shore. It is just like a spit bird, but due to strong wave, rather due to strong littoral drifting and longshore wave, the end of the spit moves east to east, east or west to the continent. It looks like a hook. That is this part. This is the spit bird. This is the spit bird. This end part of the spit that part is projected towards the open sea and moves and to east or west towards west of the continent, and it looks like a hook shape. The curves of spit assume the shape of hook. That's why it is called as a hook spit. Okay, one of the special characteristic of hook spit is that hook are stabilized when there is an equilibrium between the constructive and destructive wave. This part is more stable and equilibrium. This is not only the result of erosional or the depositional. Here, this part is more stabilized due to destructive and the constructive wave. So, hook spit or the curved spit, it's nothing but the nothing but the evolutionary form of the spit bird. The end of the spit that part is projected towards the ocean looks like a hook shape, and this is the result of both what depositional and transportational and the erosional, and it is most stabilized part. This is known as hook. Next one is the loop. Loop is the evolutionary spit or evolutionary form of spit and the curved spit, rather hook. Suppose this is the spit. This part is spit. This part is hook and this part is spit. Okay, when the opposite current become more dominant, opposite current means this is the longshore current. Here the Suez is coming and green color backwards is moving towards the ocean at the almost at right angle, that is 90-degree angle, and this is the continent or this is the shoreline. And longshore current, this is longshore current or longshore drift moving towards the or moving parallel to the shoreline. So in such circumstances, that is the parallel bar parallel to the shore developed, and this is known as pit, and it's moved and looks like a hook shape. It is known as hook bar. If the among in such circumstances, if the opposite current, opposite mean opposite to the longshore current, opposite to the longshore current become dominant than the littoral current, than the longshore drift or longshore current, then spit are bent to a such way or to a such extent that they are attached to the mainland. So, then in such circumstances, which are attached to the mainland. Okay, and it looks like a complete loop, and its center part, the center part of the loop, enclosed by the ocean water, trapped by the ocean water. Okay, in enclosed sea, that is known as lagoon. That enclosed sea is known as lagoon. Lagoon, and that enclosed loop-like bar known as loop bar. Sometimes that loop bar formed the island. Then it's known as it called as a loop bar or looped island. Next one is the connecting bar. Connecting bar is nothing but a bridge. It's a bridge like bar. It joined the island. Suppose this is the island and this is a bar, and that bar connect this island. This is known as connecting bar, or it's just like a connector. It's just like a bridge between the main continent and the island that is in the shore zone. Next one is the tombolo. Tombolo is nothing but the connecting bar. There is a simple analogy that helps to develop the tombolo. Suppose this is a barrier and wind is coming from this direction. So this is the leeward side and this is the windward side or the shadow side. So wind may be deposited in that part. Okay, and that deposited part with the time through a time and developed a connecting bridge like landform on the coastal zone, that is known as connecting bar as well as the tombolo. Suppose this is an island, this is a bar, okay, and wind is moving, and also the ocean current is moving, and due to the wave shadow zone, this part is very shallow, and due to the wave shadow zone, the sediment deposited in that part, and through a time being, this part act as a bridge with the mainland. That kind of connecting bar, this is a sort of bar, is known as tombolo. Tombolo is very common in the western coast of India near the Ratnagiri and the Malvan region.